In this video, let's talk about in Ubiquiti UniFi mesh networking, whether or how you can do DC chain. In the very beginning, let me put the statement here. It's strongly unrecommended to DC chain your access points in mesh networking. In the left side of the screen, I show you a help document from Ubiquiti. Here it says you need to minimize the number of wireless hops. In the right side, I show you an example. If you do have DC chain situation in your network topology, you will see this warning. This device is meshed with a wireless parent AP, and you may want to consider meshing it with a wired parent AP. Okay? So apparently, everyone knows it's not a good idea to do DC chain, right? But in some rare situation, for example, temporarily you do want to have a AP in a very long distance and you have trouble to do wiring. Either it's too far away or it's not very easy to do physical wiring. Let's explore if you have to have a DC chain topology, what it will look like, and what type of performance you can expect. This is my lab environment. I have 4 UniFi access points in this video. Only the first one, U6 Enterprise, it is wired with a PoE switch. Or the other 3, they will be meshed to the network. And we will explore the backend status for the 3 meshed access points, and we will test the network performance in different situations. This is the screen layout I'm going to use for this video. See, in the diagram, I will use 2 computers in the testing. One is a Linux machine directly connected to the switch. It has 10 gigabit connection. I use this high speed just to showcase in some situation you can achieve faster than 1 gigabit speed. Okay, and then I'm going to use a Windows physical machine to connect to different APs. Let's see how the network performance look like. And from time to time, I'm also going to use this Linux machine to log on to different APs to show you something in the backend. In 2 of my previous videos, the first one is about how UniFi mesh network works. The second one is about how to set up the uplink priority. So in this video, I'm not going to talk about those details anymore. I will directly show you the current situation in UniFi network topology. In the upper part of the screen, you can see the current topology already. Those 4 access points, they are DC chain. You can confirm from the dash line here for the 3 APs, right? They are meshed to the UniFi network. I have this Linux machine wired with the access point. It's 10 gigabit connection. And in the other end, I have the Windows machine. Currently, it's connected to this most remote AP, the U6 Lite. Let me SSH to the U6 Lite to see why it's connected to the U6 mesh. Click on it in network controller and we can get its IP address. Then in the Linux machine, let me SSH to it. Okay, I'm in. Let me run the command WPACLI to interact with the WPA supplicant. Let me run the command scan to scan the wireless environment. It is the very last node in the DC chain, so the network scan will take a long time, much longer than the very first U6 Pro. After about a minute, finally it returned the result. Let's try to go through the results to understand the scanned environment information. So it returned 4 BSS IDs, so 4 access points information. Why 4? It should have only returned 3, right? We only have other 3 access points in this UniFi network environment. In fact, the third one, you can see it has different SSID. It's from my home network. Remember, this is just my lab environment, right? In my home network, I also enable the mesh networking. So it's also broadcasting the vWire SSID. But apparently the third one won't be selected by the U6 Lite simply because it belongs to different network, right? So then let's check the other three. Let me pick the first one as example. It has the BSSID 6A something. In the left side, in the diagram, I marked their BSSID in the address information. So you can see the first BSSID is for this access point, the U6 Enterprise. In fact, it has the highest weight. In my next video, I'm going to explain how the weight information is derived. In this video, as long as you understand the AP with higher weight number has higher priority. But why this U6 Enterprise is not selected as the parent AP? Simply because this is my lab environment. I don't have that big room so that I can have the real world DC chain scenario, right? I simply simulate the DC chain. I manually set the priority to force this type of topology. That's why you see for the U6 Lite, even though the U6 Enterprise should be chosen as the parent, it didn't because I forced the DC chain, right? And then another very important information is the hop number. If you watch my next video, you will understand the hop number dramatically impacted the weight number calculation. In fact, it's one of the most important factors to be considered by the AP when it comes to selecting the parent access point. Okay, so this is just some explanation about why U6 Lite chose the U6 mesh and why this DC chain situation is formed. After getting that out of the way, let's test the network performance. Whenever people talk about DC chain in the mesh network, people will always mention the performance impact. Let's see what's the impact you can expect. The first testing scenario is I just moved the Windows machine very close to the U6 Enterprise so that it will connect through Wi-Fi to this AP instead of the other meshed AP, right? So in this way, we want to see what's the best possible network speed the Windows client can get in my lab environment. So in the Linux machine, I already run the iPerf3 server, and from the Windows, I'm going to run this iPerf3 client. You can see I run 10 parallel threads. Let me run it. Okay. So the performance is very good, very stable, about 1.5 gigabit per second. From the Linux activity monitor, you can see the same effect. Very stable, very good speed. Okay, so this is the ideal situation. In this testing, the mesh network is not a factor because the client simply connect to the wired AP. I will move this Windows machine to a new location to make it very close to the U6 Lite so that let's see in the worst scenario what performance we can get. Now in UniFi network controller, you can see the Windows machine is connected to the U6 Lite through Wi-Fi. All the other things, the locations, the devices, they are the same. I only changed the physical location of the Windows machine. So let's do the exact same iPerf3 testing. Let's see what's the performance we can get now. Okay, so it's very miserable, about 100 megabits per second. Okay, and it's very stable, it's 100. Just because the Windows machine is connected to the node at the end of the DC chain instead of the beginning one, the performance is so different. In my next video, I will explain the performance penalty. For this Windows machine to talk to the Linux machine, it needs to go through 4 access points and it needs 2 additional hops. Each hop basically will reduce the real network speed to half. That's why in the end you have a very miserable network speed. Of course, another reason for the excellent speed when the Windows machine was connected to the U6 Enterprise was because of Wi-Fi 6E support. If I switch the U6 Lite and the U6 Enterprise in the DC chain, then of course the Windows won't get that high speed, right? But the conclusion is the same. So you will get much reduced speed if you connect to the AP at the end of the DC chain. So this is a very simple video. We don't have many technical details. I will explain the network penalty in my next video. Okay, thanks for watching.